I'd like to introduce our next speaker, Claus, who is coming from Houston, Texas, and is with Telecom Manager. You may recognize Claus from yesterday's panel that Kat Gorinsky was the moderator for that panel. It was talking about Python and Rust, but we have today Claus to talk about Python, Go, and Rust for network automation in lovely battle. Claus is coming from Telecom Manager and is joining us from Texas today. And this is his second time because yesterday was his first time. Well, welcome to Nanon, Claus, and we'll take it away.
Thank you. Good morning, everyone. It's a pleasure to be here. Today I'm gonna present this this lovely battle. It's not yet there. Should I press play here? Oh, here we go. I found the icons, put them together. It took maybe a few minutes to do some shading there. Anyway, the idea here is like is to present a more interactive and more conclusive analysis between those languages. My background is a network engineer. I transitioned to software developer, and I know the pain it is to be a network developer, which is a mix of both. And so I brought a little bit of items here. I have not memorized all of them, so I put 100 and something pages here. I hope I can do it in time, but anyway, let's go. So let's do it. Most of the things I've done here, it's my own opinions. So don't take it anything here, regardless to any other organization. I represent my company here, but this is my my opinion, not my company's. So we can find this beautiful picture on the internet, which is Python Go, because this fight has been already for some years. But I would say that Rust is coming, and it's coming a little bit. So I put this as a funny idea here to put another button. So if you get confused between Python and Go, you're gonna get more confused now with Rust. So I created a table, so now we can actually discuss each item, and then for each languages, and let's put some numbers here, and then we can have a winner at the end. That means that we're gonna dive into those items here, language, release, and implementation first. Okay, so Python is a very mature development life cycle. Was created by Guido, and there are a few URLs here you can actually have a look. And I don't like the logo. Logo is too simple, right? But you can find a funny one, like with two snakes each other. I only found that one, which is sad. I wish I could buy another one anyway. So in 2008, around that, they introduced Python 3, which for all people that have been working with Python knows the pain, migrating from 2 to 3. And Python 2 was actually not being supported anymore since 2018. Now it's just Python 3, and the last version is Python 3.13. They follow the major, minor, and micro standards for software release. Basically, the major is not going to happen soon, which is Python 4. And minor and micro normally happens, and normally every 2 months. Python has more releases compared to other languages. Here is a beautiful picture you can see for the versions. And Python has lots of implementations. Something come new to the language is because it was implemented first on CPython. CPython is the, let's say, is the interpreter for Python. It's the full one that you install on your computer. 99% of the developers in network engineering, they don't know there is other implementation like PyPy. This is the reason because the default implementation doesn't even ask you if you want to install PyPy. But there's also a good reason. The other implementation will not probably work for the last version. So if you have a last version of Python you have in mind and you want to run your computer, probably it's not going to work in PyPy or Numba or Jython or MicroPython, etc. So you have to see which version are you using, and then you can use another implementation. There's other implementations or other things like Jupyter notebooks and other things for network engineers to do proof of concepts. Let's go to Python now. Go. Go was a little bit younger, 2009, and we have Rob Pike and Ken Thompson here. And there are lots of videos from Rob Pike if you want to understand about other interesting features on Go on YouTube. You can download it. It's really interesting. And the last version is 1.22 in 2014, 2024. And there is a funny, beautiful gift. You can buy a mascot, and there are thousands of different ones. So it's better than Python if you want to have a mascot on your desk. The release versions is similar to Python, a major and minor and a patch. And they have a very like rigid release cycle in terms of you have a summer, winter, freeze. So they are, in terms of this cycle, is more organized than Python. They have also several implementations. Originally it was written in C, the compiler, now it's written in Go, which is interesting. So the own compiler, it's written in Go. And you have other implementations like TinyGo that can run very small. And so it's a good thing to know. Also has kernel OS implementations like Gvisor and other ones. The other ones that I put here is being not updated for a while, but they was created. So Rust is a newer language compared to the other two. And the last version, and they also have a mascot, and you can buy it's a crab, a little crab, which is kind of cute. And in 2024, like this year, I think March 8, it was released the last version, 176. Rust has also the same idea of versioning, which is major, minor, and patch. And is released every 6 months, which is quite similar to, every 6 weeks, which is kind of similar to Go. It's a little bit more frequent. So the last one was 176. When I wrote this presentation, this table was 175. Now it's 176. Rust also has OS and kernel implementation like Redux, and also integration with Python. So if you really wanted to have your Python code, you can use Rust and integrate with your Python code that you don't want to change. Okay, so in this virtual battle for language release and implementation, I would give 10 for all of them because they are pretty updated. And implementation, I would say that Python wins and Go goes second and Rust last one, so 9, 8, 7. So in our table, we've got those numbers now. Let's go to the subject that everybody loves when you're talking about Go against Python, which is memory and speed. Those are the funny things that I found on the internet. And the most funny one is this ghost talking about Python 2.7 and they run away. Was a horrible migration for who works on that time. Okay, let's go. So it's important to understand that Python is interpreted and Rust and Go are compiled. And that makes a big difference on how you use the language. Python, using CPython, mostly interprets the Python in bytecode. Here is an example how you sum. It's it's very easy in Python. You can see the difference here. You don't have to do anything. You don't have to write a main function. You just write those 3 lines and you have the sum. And you don't care about the type, which is easy, right? On the bytecode, you can see how, what is created. Normally, you use this module called this to see your code. This is an example. And they are stored on a cache. So every time you run Python, it basically translates to the Python bytecode, which is PYC. The CPython distribution does not have a just-in-time compiling, which is a thing that makes Python really slow. And PyPy is the other implementation that does have a just-in-time compiler like Java, and does makes much faster. But the problem is because Python concept of other things like polymorphism, dynamic typing, and other introspective features would not allow to work properly in a just-in-time compiler. It makes probably the same speed or even worse. So this is a comparing PyPy to Python. So some of those basically much faster than the others. Those are benchmarks. Those benchmarks, you can see anything there. You can go on the site and they explain the details on each benchmark. As you can see, in some cases, PyPy is like 50, 100 times faster than Python. So if you have already a code in Python, you can just try to run PyPy. It's just like that. And if you run faster, you got a point, right? So PyPy excels for things that are more simple. When you have more complex code, you're not gonna work well. But the big advantage is memory management. PyPy uses garbage collector and traditional algorithm, and CPython uses the autoreferencing counting, which is the thing that makes Python really slow. So if you have a large dynamic code, probably PyPy will not do anything different. Now let's talk about parallelism and concurrency. This is the definition I found for some microsystem. Now it's Oracle, but basically it's important for us to keep in mind that the difference between those two concepts is one is dealing with things at the same time, the other one is doing things at the same time. It doesn't mean that they are actually the same thing. The other concept that I want to discuss, this is my definition. Processes are independent tasks that have their own memory space and their own context. And have threads that are like a smaller, lightweight process, let's say, with a smaller context and sharing resources like memory. And you have routines, which was going to be even smaller. And we have two concepts when you're talking about that, is the CPU-bound task and IO-bound task. For network automation and networking, basically we are IO-bound. So CPU-bound is not much the problem unless you do lots of calculations. Like, let's say you have to calculate the jitter or 1,000 nodes and something like that, and so you have to run 1 million nodes, 1 million interfaces, and then you have to run loops and do calculations. Then you might have a CPU bound there. The majority of the application is going to be IO bound. That's the reason Python is still very popular in networking, because it's IO bound. But even IO bound, the problem is Python, if you have IO bound and write threads, you're not going to use another core because of one thing that we're going to talk about. So Python was introduced in the threading model in 2005, and I think was a disaster. In 2008, they created multiprocessing, which was useful. In 2014, it comes with async IO, which gives a better performance for Python for IO bound problems. Like you want to ping 1 million nodes, you can use async IO and you get good performance. But you're going to use only one CPU. But it's not a problem, because if your 1 million nodes are on the internet, they're going to take maybe 10 milliseconds or more. So that's enough time for the CPU to process. However, if you're doing the same in a closed network, when you have microsecond, nanosecond response, you might have a problem, and then you won't be able to use async IO by itself. You might have to combine with multiprocessing in Python. Okay, so the problem with Python is this guy here, is Jill, and it was created for making simple the code and all the dynamic things and interesting things that Python has of simplicity. And that's because of the reference counting. So that means if you want to create two threads, they're going to block each other. If they're not going to run at the same time because of this reference counting. So this is an example I created. It's very hard for you to write a benchmark. Why? Because the language implements things differently. So if you just write a counter, for instance, a countdown, in Python it's going to have results, and Go is going to have a much better results, and Rust is even better. Is because the compiling normally do some optimizations and then find out empty loop and remove it. So there's no point of that. So in this loop, I just did like a plus and subtraction instead of just adding numbers, because I found another problem, which is large numbers. It's after 64 bits, you have to use large numbers on the languages. Python doesn't have this limitation, but in Go and Rust, you have to use large numbers. So to compare, I have to create this weird flip sum algorithm. So running here in Python, I got around 80 seconds and use around 10 megabytes in memory. So if I do the same using threads, I use more memory and I don't get much improvement. And I use 100% of CPU. So I don't use any more cores or more CPUs on my environment. When I go to multiprocessing, I can actually have 4 processes running in parallel, and they got around 400% CPU, but I use 17 megabytes of memory, which is 70% more. That's expected because of processes use more memory. So I did the same running between Python 3.12 and PyPy 3. PyPy 3, it's at the moment of my testing was 3.10. It was not 3.12, so it's behind in terms of implementation. But you can see the difference here. It's huge. Like the loop in one was 80 seconds, the other one was just 2 seconds. And when you go to multiprocessing, it goes around 1 second for PyPy, and for Python normally it's 20 seconds, so it's like 20 times faster. If you do in Go, and the first Go without any Go routines or any parallelism, you get already 1 second, which is much faster. And use much less memory, just 1 megabyte. So the difference is huge in memory and also in processing speed. And the same goes if you use Go routines. The memory doesn't change much because Go routines supposed to use really low context, so it's even better than threads on their explanation. And the time here goes under 1 minute, right? So it's less than 1 second. Sorry, less than half second, which is pretty good. Let's go to Rust, and Rust wins if you run the compiler with the optimization. In terms of memory, it's almost the same. In terms of time, it's almost the same as Go. In this case here, it wins in multi-threading. It's just 2 megabytes and use the 4 processors, 398%. I use the time Unix command to actually visualize those parameters. So this is the comparing for speed. You can see the Rust and Go is much faster than Python or PyPy. And here's the memory usage, the same thing. CPU as well. You can see that the GIL is actually blocking Python to run more than one at the same time. So that's the reason it uses only 100% CPU. It doesn't go to a 400. And I've done another example. I've done a few examples running that, and you can find in my GitHub page. BR Nuts is not my surname; it's Brazilian Nuts because I'm Brazilian. So it's BR Nuts. As the thing I found funny when I go outside. Oh, there's Brazilian Nuts here. Okay. Anyway, so BR Nuts and /nanog90. There are a few examples there. Then you can see here the speed for finding prime numbers. The prime numbers was 1 to 10 million, which took forever in Python and much faster in Go. And if you go to Rust, it go even faster. It's like basically 4 times faster than Go. This is the memory usage. Rust 2 wins. And CPU utilization. The thing here is interesting because you can see it's not using 400%. It's because of my algorithm was actually wrong. Not wrong, but it didn't use the full capacity of the 4 processes. This is important to understand because of how I did the algorithm. So it's important to understand how you're going to make it things parallel, because maybe your code's not going to do what you want. So that's an example. Also done the countdown that I explained, the empty loops, the compilers remove it. I did array, but then use lots of memory, and sometimes I think it's not maybe a good example, and not other examples. So you can find community benchmarks. This site, benchmarks games team, it's really interesting, and it ranks lots of languages and like C, C++, Sharp, Zig, and etc. And Rust wins in lots of them, even from C. Like on this example is finding the pi digits. Rust wins even like 60% faster than C implementation. And here there are lots of different ways to compile. So that's when you have a number like Rust /4, and how you implement this algorithm and how you compile. So it's very complex. If you want to dive into that, it's interesting. So those benchmarks are not much interesting for network engineering, right? Because it's mathematical calculation. You don't want to know the pi numbers in your network automation. But there are some people that did some benchmarks for comparing those languages and of a real scenario, like David did this, which is pretty nice, interesting comparison. And you have the transfer speed here, which is interesting because Go wins in terms of HTTP transfer. So if you want to write an API, Go is faster actually than Rust, but that might be because of the implementation he's using, which is hard to figure out, right? You have to go dive deep into his analysis. So it's for that, Python and CPython is really bad for memory footprint. It's just horrible. It just uses a lot. So if you want to run lots of process, you're going to need lots of memory, and maybe it's not worth it. In speed and parallelism, Python is bad, and PyPy it's better or good. Rust is great, and Go is great. Okay. So, and this table, we've got 10 for Rust and 10 for Go, and just 5 for Python. Let's go to the next one. Deployment and dependencies. This is the nightmare for everyone. Okay, Python importing models is a nightmare. It's not because of the process running. It's because when you do the upgrade. When you do an upgrade, you're going to have lots of files being touched and modified. And this is an example of running Python. And it's the strace Unix command that you do opennet. So you see which files you're touching. And just importing Paramiko and PySNMP, which is 2 simple modules. Imagine if you have more imports. This is 269 files. That when you run Python, it opens 269 files. This is a nightmare for deployment because you have to make sure all those files, when you change a version, is compatible, right? So upgrading deployment is a nightmare. I have some examples here, people talking about that, and you can find on the internet, and it's pretty bad. And I face on my laptop problems with that because I install using RPM instead of APT or Snap, and there are so many tools you can upgrade something, and that is bad. So you have to understand exactly how the deployment, the implementation of Python and the modules are done so you can do a proper job. If you don't understand, you're going to do something wrong. In Python 3.3 in 2012, they created the virtual environments, and that makes it a little bit easier, so you can isolate those problems. And also you can create requirements.txt, which makes sure you're using the right versions. But the language itself doesn't support that. Okay, and Python has PyPy, which is very nice. You have all the packages there, and you can find lots of good resources there, lots of things already done for you. You just have to import and install using pip. Go is a little bit, it warns already with the dependencies straight. So you have go mod and go sum, which store the dependencies and the versions and the hash of the commit you're actually using it, which is pretty good. And then you can make sure you're not going to run into problem with dependencies. So this is pretty good. However, you're using here open like GitHub. Golang.org is a little bit more controlled, but GitHub, you don't know what people put there, right? So you have to be careful what you import in here and make sure the code it has the rights or licensing, and also there's no Trojan horse or whatever. In Rust, on the other hand, we have Cargo, which is like it's a very good tool and use crates, which it's audited a few times. So he's showing how the Cargo lock works with it's similar to Go. We have like the hashes checksum for all the versions you're using, but it has crates, and crates.io is like PyPy. You have lots of modules there, but when you publish there, all the codes that publish in crates.io has to depend on the package that also the modules or codes that are there. So you cannot have external dependencies like GitHub. So if you're using some from crates.io, you're going to be fine. And Rust, it's very focused on security. They'll have rustsec.org, which runs audit on that crate. So it's pretty good in terms of security, and you're going to feel more comfortable using it if you import from crates. So in this case, I will give 10 to Rust because it's better. It's better designed for deployment and dependency, etc. Because it has all the good stuff it has in Rust compared to Go and Python. Let's go now for program logging, error handling, and exceptions. Python logging, it's introduced in 2008, and it's very easy to use. There's no problem. It has lots of structure logging. It's very complex and very, how can I say, extendable, has hierarchies, and it's pretty good logging in Python. In Go logging, it's not as good as Python. If you're used to structure logging and then hierarchy, you're going to be frustrated using Go. Go doesn't have that properly. In 2023, last year, they introduced the structure logging. I haven't played with it, but looks like they are improvement. But it's not like Python. It's still not that as good as Python. So you can import other logging, right? Like people have created other logging for Go, which is much better, but it's not included in standard library. I'm talking about standard library here. In Rust, doesn't have any standard library for logging, so you have to use some crates. And they have great crates for logging as well in Rust, but they are not standard library. Python error handling, it's based on exception and traceback, which is, for me, it's really simple, and it's avoid complications on the developer side. I don't like when you depend on the developer. It's not a good thing because every developer is going to do something different. And I know that you can put some rules and you can have AI to control people, but it still have a problem. Because Go, for instance, you have to return the error and you have to give it a context. And here is a very simple one that you divide by 0. But when you have more complex things and you have like a cascade error problem, you have to concatenate the error, otherwise you're going to get lost. And this is really easy to find. So the Go error handling, it's up to developer to do a proper thing. I mean, it's the same in Python. You have to do a proper thing, but you have traceback and you have exceptions, so you can see where in the code is the problem. But for instance, I was working in this code here, is a turn Python, which is a Go development. And the guy just returned the error, he didn't put the context. You can see here, in the first line here, if it finds an error, it just returns the error and doesn't put that was found on get from. And the other matters like performance transaction, which is down there, is returning the same error, and it's not because it's the same function, and you get lost. So I have to put those logging here, and I've done that previously as well, which is a nightmare. So you don't want the developer to do error handling, otherwise you might have a problem like this one here, this code here. So Rust error handling is a little bit more better than Go, and it's more comprehensive, and it's richer and has also a better structure. This presentation, I think you guys gonna have access, right? I put all these references here so you guys can have it. I'm going a little bit fast because there are 100 and something there. That's good. So in terms of versus battle here, we've got Python winning. Python it's better in logging in error. It's just easier, and it's a little bit how can I say, maybe lazy to use Python because you don't have to go in the greedy details. However, I would prefer to do that than finding someone else's code with error handling completely wrong, which is a pain to change because you have to understand all the context everywhere. So it is my personal opinion. I give 10 to Python. And this is the funny picture that I've seen yesterday. I think the other colleague that did the presentation is on the left here. You can see error, like different to new, and then return the error. That's the thing people do, which is wrong. You have to put the context of what you're doing, or otherwise you're going to be cascading something and nobody's going to get the context. So that's the problem. Okay, so let's go to IP network native libraries. This is what matters for us as network engineers. Python does have some network libraries introduced a long time ago, like sockets and SSL, which TLS, and HTTP, HTML in your lib in 2008. And in 2012, version 3.3 was a huge improvement, which is IP address, which is a standard library to dealing with IP. It's really good in terms of IP manipulation. You can get subnets, you can count subnets, you can compare nets, and it's a very, very complex and very full of features standard library, which is pretty good. I was working with 2.7 at that time. I remember they came with this, and then I migrated to 3 just because of this module, because it was much easier to work with IP, and it was a standard library. Go does have some network capabilities as well, like standard libraries for network, like RPC and HTTP, cryptography as well, and Rust does not have. It's basically all on crates, so they don't have a standard manipulation, but has a standard IP manipulation a little bit better than Go. And so in this battle here, Python wins again, 10-9-8, and the second is Go, and the last one is Rust. Let's go to network access methods and tools. So this thing here, it's interesting because we're gonna have to talk a little bit of history of connecting to the devices, right? A long time ago, remember working in 2004, 1994, 1995, the only way to get information from a router was actually to access via telnet. They didn't have even SSH. We had SNMP on the time, but most of the information we really needed was actually on telnet. The MIBs were like very shallow in terms of information. So we need to write programs in Perl on that time to access the router and get information, or access the router to write information. And that was a long time ago, but still people do it. So people still access the command line interface to do things on the router. That's very common. There are lots of standards that try to remove this, but I don't think it's going to go away, because still have things you have to do from the command line interface. And so it's important to understand how those languages deal with it, like how they deal with the remote access, right? The other thing is still some people still using is SNMP. SNMP version 3 was created to try to make people writing things there with security, but SNMP never been used for writing. Nobody uses for writing. Normally SNMP is for reading. You don't use it for writing. You use CLI normally for writing. There are some private APIs, and then it comes the standards, right? Young models, and at conf that was trying to give some more context, run away from CLI commands and use some more structure thing. But I think it didn't go much further. So you can still use it, but I think SSH is still winning nowadays. And then we come with gRPC and GNI and GNOI, not GNOI. And so the difference on them is like pool and streaming telemetry, right? The pool ones is the one you go and get like private APIs, CLI, and SNMP. We'll go there, hey, give me information, and we return. The other ones, it's more modern, and it's gonna come soon, but this idea is really long, right? Like SNMP traps. They're basically streaming telemetry, right? But when SNMP traps were created, the MIBs available was just alarms, like, oh, interface down, or whatever, memory is up, or whatever. So they didn't have management in terms of number of bytes and packets on the interface. It was just like alarms. So people use it some SNMP trap for a while, but we have NetFlow and IPFix and all those technologies still being used as flow-like, and syslog, which is still a Unix thing, and some routers still use those protocols as well, which is you receive the information even you're not requesting it. So this is like a timetable for those technologies. It's kind of gRPC is a new kid on the block, 2016. And I think it's the future for getting information from the network, especially really large networks. And imagine you are in a closed fabric and you need to get information from all the interfaces. You're not going to do that with SNMP. It's not a good tool to do it, because maybe lots of interfaces that have no traffic at all, and you're just grabbing information that you don't need it. So gRPC would be better to use, or other techniques like, I don't know, maybe NetFlow you might be using. Okay, so how is CLI access using Python? Python is like, before Python, Perl had it, and I use Perl a lot for accessing routers. But Python has grown a lot. The community has lots of modules that do job for you. Like Paramiko is the most famous one, like more low level. And then comes NetMiko, which goes over Paramiko, then gives you like more complex for the router. You can choose Cisco, whatever version. And Scalability came later as well, and it's pretty good. But those ones don't support concurrency, right? It's important for Python to run faster. You have to use async IO, otherwise you're gonna need process, and then you have that problem with memory and context. So you have to search, if you want a performance, you have to search, especially for IO bound things like we have in network. You have to search for async IO aware modules. You have to have implementation that, otherwise it's not going to work. Like using async SSH, right? Using async SSH, you can actually send thousands of SSH, and they are not blocking each other, and they can run concurrently on the same CPU, and you get all the information you need in a very fast time without any blocking. You don't need to create a process. You just need to do the async IO. It's a little bit complex to use it, but once you learn, it's fine. Scraply has also a async IO module, and here there's some example like using subprocess, using SSH or full operation system, and Paramiko, which is a little bit more elegant. And then you use NetMiko, which it's hiding Paramiko there, and you can see you put the Cisco IOS there, and Scraply, which is similar. And then using async SSH module in Python, which is it's important to see here the async has this await thing. When you put await, it means that it can unblock the function, which is ls in this example here. Scraply Go has also a plugin that has async IO. Here is example running on Cisco IOS XC. Okay, let's go to Go. CLI in Go, it's not as how can I say, you don't have much implementations like in Python, but it does have some. And it also has Scraply, which he calls Scraply Go. It has a very interesting implementation by Yahoo called vSSH, which is you just run thousands of SSH really quickly using Go routines. And there are much others, and those are the ones that I chose here to show. Here are some examples using the OS SSH, which is not preferable, but some people do. Using the crypto SSH library in Go, and using Yahoo VSS. And you can see it, you can do easily a code of thousands of nodes to get the version or whatever you want to really quickly. In Rust, you do have also a few libraries. It's actually not as long as Go or Python, but it also has Scraply. I think the developer of Scraply decided to make it popular, so he put the Scraply Rust as well. But it's not on crates. Means that it's not a good idea to use unless it's on crates, from my point of view. But it still have the implementation there. And I couldn't find anything like NetMiko for Rust. So CLI, it's not that great in Rust. SNMP, that if you still have to collect something using SNMP, Python has all the libraries. You have me parsers and have everything you want, including async IO SNMP modules, which makes you much faster running concurrently. Go does have as well, and Rust also have, but it's a smaller footprint compared to Python. Netconf, RESTconf, and Young, Python has, Go has, and Rust also has. So you can use either language to work with those protocols and this standard. Now we're going to go a little bit more interesting with the gRPC, and gRPC basically uses structure data, protobuf, and communicate much faster compared to the others, and allows streaming, which is interesting. In Python you do have, but most of the Python implementations are not in Python. It's on C++ or even in Go, which is it's the way it is. Go does have, it's very nice. gRPC in Go, it's okay, it's good. It's a way to go, I think. In Rust, it does have as well. It's tonic, but it's in crates, and I didn't find as interesting as Go, but it does have. So GNMI, which is on top of gRPC, use young models, and basically you can get the same information you got from SNMP, you will be able to do with GNMI. However, there's no other all routers use it, so you might have to select the nodes you actually can make a GNMI. So this is like a direct translation for who's really familiar with getting the SNMP MIBs here on your right, and your left you have young model, which is the same thing. Like if you want to get the high counters for input octets, is the same in young model, and then it's easy. And GNNI has some operations here, some examples of using it. And you have also tools written in Go to use GNNI. You don't have to write your own code. You just have to download this GNNI IC, and you have a server and client implementations. Arista has, it contributed a lot, Juniper as well. Nokia and other players are contributing a lot for this standard to go up. So here's an example in Go, getting information or state the counters in octets, which is a little more complex than using SNMP, but it's not as complex as some people might think. So it's good if you're planning to do a better telemetry, getting more information of your network, like you have a clause implementation with maybe thousands of interfaces, and you want to get information faster. That's the way to go. Netflix created this GNMI gateway, which is really interesting idea. It means you can have redundancy, and you can have a proxy that does for you and collects, and you have the same information everywhere. There are more details on that on the internet, but it's an interesting idea. That is I think is a good thing that you can already use it. And GNMI for Rust, I didn't find anything for Rust. Of course, you have Tonic and you have gRPC. You can implement yourself, but it's not as much as in Go. And GNOI, which allows you to do commands on the router, which is similar to SSH, CLI, right? But it's more structured way. Not sure if this is gonna take off, because I still think SSH access is very strong, because have some capabilities like you can have users and you can have authority. You can decide which user gonna do which command. I'm not sure if this allows such a thing. Maybe allows it. I didn't investigate much on that. And you do have in Python and Go, and not in Rust. In this here, I want to explain a little bit more in terms of private APIs, which all of them has. So if you have access for a cloud like Amazon or Microsoft, you're gonna find basically APIs for all of those languages. So you're not gonna have a problem. And you can go a little bit lower level, and that's a very interesting thing, because in Rust you can manipulate NF tables and run pcap, and also in Go and also in Python. But Python still have not implemented in a sync module, so it's not performatic, and so you're gonna need perhaps Go and Rust. So if you want to make let's say changes on routers that you run like Linux, and you have NF tables, you have 1000 nodes, and you have to update all of them, the best is to go Rust or Go. You implement that easily and deploy easily, and run it faster. And Python, you're not going to be able to do it properly. And Rust has Linux towards, I think it's like Rust, so it's a kind of interesting thing, that some media on this integration between Linux kernel and and Rust. And Redux, which is the Rust operation system written in Rust, it also has lots of force now to integrate with Linux applications, which is interesting. So Rust is very strong on more lower level, which is interesting to know. So in this versus battle here, network access methods and tools, I will give 9 to Python, 9 to Go, and 8 to Rust. The reason here I didn't do more in Python is because gRPC is really weak in Python, but it's stronger in other things like SSH and CLI, and Go is not as good. So 9. And Rust gets 8 because no many implementations, so unfortunately. But Rust is a new language, maybe in the future. Let's go to network automation community tools. That's Python wins a lot because there are so many implementations, there are so many tools that can use it. It's those here are just a few of them. There's so many, and it's difficult even to find one and decide which one to use sometimes. Python has lots of other implementations like Mininet and people writing automation and like Salt and Ansible. And so Python, it's a very large community for network automation and frameworks, and it's a large community. Go is not as big as Python, as everybody maybe know, but it does have really good tools like Terraform and Telegraph and Go BGP, which is it's really performatic and it's good for you. Like if you want to write, for instance, a looking glass, I would go to Go BGP for getting tables, and it's a very good daemon and good performance. Has a gRPC interface, which is easier to interact with your code. Yeah, so, and Rust is not as much implementation. It does have a Rusty BGP, and it announced that's better than FRR. Who plays with FRR? I haven't played with it, but I would love to see it and compare with Go BGP. Maybe that's the next topic presentation. NetBricks as well, and not many higher level tools. So Rust is lacking higher level tools. So in this score, Rust loses it badly, goes to 6, and Go got 8, and Python wins very easily here because it's has a huge community behind. So I didn't include on this presentation lots of things that would also make the difference between those languages, and you might choose one because of the other. Like the environment you're actually writing your code is important, right? If you have an environment that doesn't help you much, it doesn't policy your code, whatever. And so I didn't do this research and to show you guys. Didn't have also time to put it here. Documentation generation. This is interesting. Some languages have built-in documentation generation, which is good. Code profiling, how you can profile your code and make sure it runs properly, which in Go and Rust has a lots of good tools, and it's very interesting. You can actually tune very heavily them, make them work really well. You can change garbage collector percentage. You can do lots of things even on the compiling methods. So in code testing also is important. And Rust and Go have unit tests built in on the which you run just cargo test or Go test, which is good, but Python does not have. So you have to choose basically between those two guys, PyTests or unit tests, which are two different models, and they approach unit tests differently. Which is a pain because some people prefer one, the other prefer the other. So depending on the team you're working with, you're gonna have PyTest or you're gonna have unit tests. I mean, it's a personal preference. And when you leave the developer to have a personal preference, you have a problem. And most of the code I've done, which I struggle with, was actually personal preference people. People has some opinion of how the code has to be done. And that is a very problematic thing if you have working with different teams, because you're going to have a different style, a different way to do it. And this is, I think you spend more time on those discussions and CRs, code reviews, than actually the coding itself. Also has formatting, which Python has black, and Go and Rust has built-in formatting, which is interesting. Linters, none of them has like built-in linters, but you can use them like Python has there. Python has lots of linters, but here are some of them. I didn't do this analysis as well. So my conclusions for today, I hope you guys make a decision of which language you're going to use. Probably it's not going to be as easy as you thought after this presentation. So the winner here is Go. on this my point here, but it's just one point, so I can be biased here. And Rust lost in a few points only. But the reason here is because I put lots of implementation here points, and Rust lost because of that. And Go win basically because of simplicity and let's say performance. Rust always gonna win in performance and deployment. It's the winner here. So you have to think your use case, right? Each use case you might have a language preference. So if you have what has more potential for network automation in the future, I would say Rust and Go. Why? Because AI is coming. AI is going to take over, and it's going to take this barrier that I just talked about, CRs and personal preference, away. You're not going to have personal preference anymore. AI is going to do that for you. So who's going to win? Who makes better? Who makes run faster? Who have better dependencies, control, and etc., more secure? So Rust is winning this battle. If you want to go in the future, I would go to Rust and don't waste time with Python anymore. So what is easier to maintain and collaborate on network automation? I would say that's Rust. It's still Rust because there are some things in Rust which is still have personal preference. You can like write the code differently, which is it's interesting thing, but it's annoying as well because some people are lazy. Instead of writing if, you can just return the comparing in a function, which is cleaner, but it's a different code. And when you have different codes, you have people with different preferences. And I don't like that thing. It's not useful for teamwork. So in this case, Rust, Go, and Python. Which one is easy to learn today for network automation? Python is winner, definitely. Has lots of resources, lots of YouTube videos. If you want to learn network automation, do something, Python is the way to go. And then Go, and then Rust. The thing really annoying about Go is the name Go. If you search in Go on Google, you're going to find anything but not the language. So what you have to search is Golang. If you search the Golang in string, and you're going to find stuff. So it's Golang, let's say, for Google search. What's easier? Let's go to the next one. I want to have an efficient, fast, and easy deployment. Of course, Rust is going to win, and Go in second. I would exclude completely Python. If your use case is efficiency and fast and easy deployment, just forget about Python. It's a waste of time. If you want easy integration with legacy systems, Python is going to win. Has lots of modules, has lots of things, and has bindings to C, bindings to Go, bindings to Rust. Python is your uncle here. If you want to write less code and you use community code, Python is winner as well because it has much more than Go and Rust. So if you want to have better telemetry and network communication, again, I would choose Go here because it has a better integration with gRPC and also has a better performatic HTTP implementation at the moment. So Rust in the second and Python. And so if I want to perform low-level solution, packet manipulation, hardware, software, it's again, Rust and Go and Python excluded. And if I want to contribute to the community, so Rust is the winner here because there's no many implementations. So if you want to contribute with something, it's the best way to learn Rust. Then you're going to have more space to contribute, right? Python has so many packages that it's not going to make any difference if you make another one. And that's it. Thank you. I've got here some of more information here if you want to get. And those codes, and it's on my GitHub page as well.